Join us as we explore the fascinating world of neural networks and understand how they work. Neural networks are the foundation of modern artificial intelligence, inspired by how our brains work. Let's start by understanding what a neural network actually is. A neural network is a computational model that's inspired by the way biological neural networks work in animal brains. It consists of interconnected nodes that we call neurons or units, which process and transmit information. Most importantly, neural networks can learn patterns from data through a process called training. Here's a single artificial neuron. It takes multiple inputs, multiplies them by weights, sums them up, and applies an activation function to produce an output. Now let's look at the basic structure of neural networks. Neural networks are organized in layers of neurons. The basic structure flows from an input layer through one or more hidden layers to an output layer. This is a simple neural network with 3 inputs, one hidden layer with 4 neurons, and one output. Each connection represents a weighted link between neurons. Let's understand how information flows through a neural network. The process of information flowing through the network is called forward propagation. First, input data enters the input layer neurons. Each neuron computes its output by taking the weighted sum of its inputs and applying an activation function. Mathematically, this is expressed as y equals f of the sum of weighted inputs plus a bias term. This process continues layer by layer until we reach the final output. Here's an example showing how numerical values flow through the network. Input values 2, 1, and 3 are processed to produce intermediate values in the hidden layer, which finally result in an output of 0.7. Activation functions are crucial components that introduce nonlinearity. Let's look at some common activation functions used in neural networks. The sigmoid function squashes values between 0 and 1, making it useful for binary classification. Re-OIL-U, or rectified linear unit, is simple but effective. It outputs the input if positive, otherwise 0. Here you can see the shapes of sigmoid and ReL-U activation functions. These nonlinear functions allow neural networks to learn complex patterns. Neural networks have countless applications in the modern world. Neural networks excel at image recognition, identifying objects, faces, and scenes in photographs. They're also used in natural language processing for translation, chatbots, and text analysis. Recommendation systems use neural networks to suggest movies, products, or content based on your preferences. In healthcare, they help analyze medical images and assist in diagnosis. Let's summarize what we've learned about neural networks. Neural networks are computational models inspired by how the brain processes information. They consist of layers of interconnected artificial neurons that process data. Most importantly, they can learn complex patterns by training on large amounts of data. Today, neural networks power many AI applications that we interact with every day, from search engines to virtual assistants.